Okay, so now let's focus on these nuclei here on the right side of the iron group. So we know from the previous video that these heavy nuclei will gain stability and give off energy if they are split into two smaller nuclei. So kaning mga bugat diri, they have to split para mag-gain nila ang stability just like that of the iron group. So many heavier elements with smaller binding energies per nucleon can decompose into more stable elements as seen in the graph on the previous page. The process is called nuclear fission. Okay, nuclear fission is the process of splitting the nucleus of an atom into two or more smaller nuclei, which are known as the fission products. So kaning mga smaller nuclei, they're called the fission products. Now this process usually does not occur naturally, but is induced by bombarded with the particle usually used is neutron. Now when heavy elements undergo fission, huge amounts of energy are released in the process, as it is an extremely so butangan gina siya diyan exothermic reaction, meaning dako gid kaayo nga amount sa energy ang ma-release if nuclear fission happens. The first reported nuclear fission occurred in 1939 when three German scientists, Lisa Meitner, Otto Hahn, and Fritz Strassmann. Now, they bombarded uranium-235 atoms with slow-moving neutrons that split the uranium-235 nuclei into smaller fragments that consisted of several neutrons and elements near the middle of the periodic table. So, kani silang tulo, actually, it took them a while to be able to discover this process, and it was Lisa Meitner and Fritz Strassmann who gave the term fission. The process, ang process kay nabuhat ni Otto Hahn, pero ang ni-interpret sa iyang gibuhat, because Otto Hahn was able to do something but he couldn't explain what he did, and it was Lisa Meitner and Fritz Strassmann who explained what he did. This story is actually really nice, and there are lots of videos showing there are lots of videos about this in YouTube about the story of Lisa Meitner. Actually, it was Otto Hahn who won the Nobel Prize, and didn't even honor Lisa Meitner sa iyahang contribution ani niya. There are stories about this in YouTube, and I want you to look at this story. So they were looking for, actually they thought that when uranium-235, when they do bombardment, they would be able to discover a heavier nga nuclei. They didn't expect, dili sila, wa sila nagtuo nga lighter nga nuclei, no? So it was uranium-235 gibombard og neutron, and then ang nahitabo is na-discover nila nga naay na-produce nga barium-141 and krypton-92. 92 na baya ni ang atomic number ni uranium niya, ang fission products kay ang atomic number kay 36 of 56, so they're lighter. So wa sila nag-expect ani, because they were looking for an element nga nana sa 91. So this, and together with the formation of these fission products, barium and krypton, a huge amount of energy is released, and there are 3 neutrons released also. Other 3 neutrons released in the process. So muna fission na discover nilang tulo. So what happens is the neutron strikes the nucleus and absorbs the neutron. The nucleus absorbs the neutron. The absorbed neutron causes the nucleus to undergo deformation, and in about 10 to the negative 14 of a second, so meaning it's really fast, one of the deformations is so drastic that the nucleus cannot recover, di niya kaya, and so it will undergo fission, mo break up siya. And when it breaks up, it releases an average of 2 to 3 neutrons, and in about 10 to the negative 12 second, the fission fragments lose their kinetic energy and come to rest, emitting a number of gamma rays. Now the fragments are called fission products. They lose excess energy by radioactive decay, because the process, the fission products, kadong katong mga product nga na-release kay they're still radioactive, so they still undergo decay by emitting particles over a lengthy period of time. So depende sa kung unsa nga particle ang depende sa kung unsa ang fission product, so it could take seconds or years for it to happen. The neutrons produced in the fission process, so di ba na neutron unya gibombard siya 235 na ay fission products na energy, at the same time na itulo ka neutron. So if there is there are many uranium-235 present, so kaning silang tulo ka uranium dire, they could be hitting another uranium-235. And remember that every time the neutron kanang goes to the nucleus, i-bombard niya ang nucleus, there is a corresponding huge amount of energy released in the process. No? So the neutrons produced in the fission process can cause additional fission processes. This phenomena is called fission chain reaction, which is if the process is unchecked, the result is a violent explosion within a few seconds. So it doesn't take a lot of time, it takes only a few seconds to happen. Now, the energy evolved in successive fission. So, kanino mo, igo ni siya uranium-235 na energy, kani 235 energy, and another energy. Unya, kadto na pud siya na napoy tulo ka neutrons, nga mo igo na pud og lain, and that's what happens. That's chain reactions. So, the energy evolved in successive fission escalates to give a tremendous explosion in atomic bombs. So, kana ding atomic bombs, ang nahitabuan na is fission chain reaction. And bongga ra ang iyahang effect. The energy released is huge, and it's really huge, no? So the Hiroshima bomb was equivalent to 20,000 tons of TNT. And you can also find videos of this in YouTube about the story of Hiroshima bombing and how it happened in relation to the discovery of Lisa Meitner and Otto Hahn of the fission, of nuclear fission. Although nuclear fission is dangerous, kay known man siya ning atomic bombs, and it's harmful, but at the same time it's really useful ang discovery niya sa nuclear fission, because this is the process that is used in the production of nuclear energy, and it's a clean energy. There's no greenhouse gases released in the production of nuclear energy. So, nuclear energy is produced through controlled. So, naay word nga controlled. Kay kaning sa pag-produce sa atomic bomb kay uncontrolled man na siya nga nuclear fission, chain reaction. For a chain reaction to occur, the sample fissionable material, or we usually call it fissile material, must have a minimum mass. Otherwise, kung dili enough ang mass, mo escape ra ang neutron from the sample before they have the opportunity to strike other nuclei and cause additional fission. So kung dili enough ang material, mo tay gitawag og subcritical mass. So mo die down ra kay wala naman siya maigo nga fissionable material. Mo die down ra ang reaction. Pero enough lang gani, so it's called a critical mass. Sustainable lang, enough lang siya nga chain reaction, constant rate sa fission. But if daghan ra, more than the critical mass, then it's called a supercritical mass. So the neutrons released for every fission will most probably hit another fissionable material. So only a few neutrons will escape. So kay daghan man siya maigo nga fissile nga material, kay daghan man, then it will cause a chain reaction which can lead to a nuclear explosion. So, muna siya dangerous. So, ang supercritical mass, muna siya gamit sa atomic bombs. So, this is just a figure showing us of the subcritical, critical, and the supercritical mass. And so, this is what happens for a controlled fission. So, constant lang ang rate, no? But for uncontrolled fission, so daghan man ang fissionable nga material. So for every neutron released for every fission, maigo gid siya lain nga fissile nga material. So here, so this is the atomic bomb. An atomic bomb contains several pounds of small pieces of fissionable material, which they usually use uranium-235 or plutonium-239. And then there is a source of neutron. Of course, for a fission to happen, there must be a neutron bombarded to the fissile material. And then an explosive device for compressing it quickly into a small volume. So when the small pieces of fissionable material are brought together quickly to form a body with a large mass, mass larger than the critical mass, so supercritical mass na siya, the relative number of escaping neutrons decreases and a chain reaction and explosion result. So initially, mo ni siya ang atomic bomb. So diri nga portion na ay subcritical mass, diri nga portion ay subcritical mass. Anya na ay subcritical mass diri. And then there is a neutron source nga initiator. So para i-combine ani nilang duha, subcritical plus subcritical, mo supercritical na siya, more than the critical. So unsaan man isla pag-bring together, so na explosive nga propellant diri dapita. So inig-explode ani iyang itud si subcritical mass padulong sa isa ka subcritical mass nga naay neutron source initiator. And then that's what happens. A chain reaction results to an explosion. So muna siya sa Hiroshima. Muna ang testing sa atomic bomb.